When we're adding behavior to a derived class, that derived class can of course have fields as we've seen. The thing is that if the derived class adds a field that has the same name as a field in the base class, it will actually hide the base class field. Let's see what that means. If we look at our code here, remember that we have our flight class, and as we've seen, our flight class has a method called add1passenger. Now inside of our add1passenger, it will check to see if we have enough seating. If so, we add the passenger. If not, we handle the case of too many. And the way we check and see if we have enough seating is that we have a method called hasSeating. And what hasSeating does is it basically looks and sees that as long as the number of passengers is less than the number of seats, then we'll say we have seating. So our flight class has a field called seats with a value of 150. So if we create an instance of our flight class and add it to a flight reference called F1, if we print out the value of f1.seats, we will of course get 150. Now if we take our cargo flight class that extends the flight class, or it inherits from it, if it adds its own field called seats with a value of 12, which would make sense, right? If a plane is a cargo flight, it may have fewer seats. If we then go out here and create an instance of the cargo flight class and assign it to a reference of type cargo flight called CF, if we print out the value of CF.seats, that gives us a value of 12. The cargo flight seats field is hiding the flight seats field. But now something unexpected can happen by doing that. If I now create an instance of the cargo flight class and I assign it to a reference of type flight that we've called F2, when we print out F2.seats, what we will actually get is the value 150. Because the seats value of 12 is only visible when the instance is being worked with as a cargo flight. Because the reference here, F2, is of type flight, it doesn't know anything about the seats value of 12. It only knows about the seats value of 150. That becomes really important as we start using methods from the base class. Right? So if I take f2.add1passenger, when that calls into the method to add one passenger, which then in turn calls hasSeating, when it checks the value of seats, it's going to use the value of seats that's defined inside the flight class, which is 150, which would allow us to add 150 passengers to a plane with only 12 seats. Now, and this is not limited to the scenario where the reference is of type flight. If we were to say cf.add1passenger, and CF is of type cargo flight, again, because add1passenger calls hasSeating and hasSeating is implemented inside the flight class, it would still use the value of 150. Because within that method, it only knows about the fields defined within flight. So you can see this idea of hiding fields is a very dangerous thing. So I'm going to go ahead and highlight that in red. Now, when we work with methods, it's a little different. Methods can override base class methods. So if you have a derived class and it has a method with the same signature as a base class method, it will override it. Remember, the signature means it has the same name and the same parameter list. Let's see how overriding differs from hiding. So we have our class here, cargo flight, deriving from flight. Same exact code we saw before. But what we're going to do here is that where we set seats equal to 150 as a field, what we're going to do is get rid of that field seats. And we're going to change it to a method called getSeats that returns a value of 150. Of course, that means that our hasSeating method has to be changed to get rid of seats and instead call getSeats. And then our derived class, cargo flight, will get rid of its field seats and add in a method called getSeats that returns 12. So now if we work with this, we go out here, we have our flight reference F1, assign the value of a new flight instance. Of course, when we print out getSeats, it's going to print out 150. If we have a cargo flight reference CF pointing to a new instance of cargo flight, when it prints out getSeats, it will print out 12. But here's where we see the difference. If I now have a flight reference called F2 assigned to a new instance of cargo flight, when we call getSeats, because the getSeats method from cargo flight overrides the getSeats method from flight, we will now get the appropriate value of 12. Right? So the method in derived class has overridden the base class method. And that's really important as we start to do further work. Right? So if I take my F2, a reference of type flight, and call add1passenger, it calls into the add1passenger method. Inside of add1passenger, we call into hasSeating. When we get into hasSeating, when it calls getSeats, because the instance is of type cargo flight, The implementation of getSeats inside of CargoFlight is actually what gets called, returning the appropriate value of 12. So it would only allow us to add 12 passengers. And that works whether we have a reference like F2 of type flight or a reference CF, which is of the appropriate type cargo flight. The method in the base class is actually being overridden, assuring that the appropriate method implementation gets called based on the type of object created, not the type of reference used. If you come from other object-oriented languages like C# or C++, something that may stand out to you here is that you'll notice that we didn't have to do anything special to be able to override that getSeats method. In Java, all methods are automatically overridable unless you do something special to say that you don't want them overridden. We'll talk about how to do that a little bit later in this module. Now, one of the things that may come to mind, though, is that, well, how do you make sure that you haven't accidentally made a mistake in terms of maybe not matching the signature correctly? What Java provides is the override annotation. And what this tells the compiler is that it is your intention to override a method from the base class. So the compiler will actually check and make sure that the base class has a method with that signature. So it's kind of just a sanity check to make sure that the method you're declaring really does replace a method in the base class. Has no impact on runtime, it's only used at compile time.